Hi class, welcome to our video on 1-5 angle relationships. We got a lot more terminology today, so we'll get ready to write down quite a few definitions. Adjacent angles is our first definition. Here's what adjacent angles are. They're two angles in the same plane. They have a common vertex and a common side, but no common interior points. So how I like to refer to this in layman's terms is it's two angles that are next to each other. So look at angle 1 and angle 2. They're two angles, they're kind of neighboring or bordering angles. They share a common vertex, and they also have a common side. This ray right here is a common side. So angles 1 and angle 2, these ones are adjacent angles. 3 and 4 are not adjacent angles because they don't share a common side. Notice how angle 3 has this green line, this green ray rather, as a side, and angle 4 has this blue line or blue ray as a side, so they don't share a common side. So 3 and 4 are not adjacent angles. 5 and 6, again, those are not adjacent angles because they don't share a common vertex. They have to have a common vertex and a common side. So if you were to have a lot of these intersecting lines right here, the neighboring angles are adjacent. If this is 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8, angles 1 and 2 are adjacent. Angles 6 and 5 are adjacent. Angles 1 and 8 are adjacent. Angles 3 and 4 are adjacent. It's two neighboring angles that are next to each other. They share a common vertex and they share a common side. So, which numbered pair of angles is an example of adjacent angles? This one is, the other two are not. Another term is vertical angles, a pretty important term. These are two non-adjacent angles formed by two intersecting lines. So 1 and 4 are adjacent. 3 and 4 are adjacent. So we're looking for non-adjacent angles. So again, how I kind of put this in layman's terms, vertical angles are angles that are kind of across from each other or on the opposite side. 1 and 3, those ones are vertical angles. Which angle pairs form vertical angles? Angle 1 and angle 3. Another one is angle 2 and angle 4. Okay, when two intersecting lines, that's when you have vertical angles. So angle 2 and angle 4. It's kind of like the ones that are across from each other. Here on 5, 6, 7, and 8, here's one line, but here's a second line and then a third line. So this one, there's no such case of vertical angles. It has to be two intersecting lines. So we could write any two lines that intersect. Here's a line, here's a line. When they intersect, this angle is vertical to this one. We'll call this angle 1 and angle 2. And then angle 3 and angle 4 are vertical. So it's kind of the ones that are on the opposite side of the crossing there. Okay? That's what vertical angles are. So looking at this figure, name a pair of obtuse vertical angles. We could get a protractor out and make sure they're obtuse, but just taking a look at what it looks like, if I could pick two obtuse vertical angles, or name a pair of obtuse vertical angles, this angle right here, CDG, looks clearly obtuse, and then the angle across from it, or its vertical angle, is BDE, this angle right here. So I would say angle CDG and angle BDE. Those two angles are vertical angles. You might have seen another one. If I would speculate, I would guess that this angle is vertical to this one. They're for sure vertical, and I would also speculate that they're obtuse. So that would be angle CEG, angle CEG, and angle AEF, angle AEF. Those would be obtuse vertical angles. More terms here. Here's a linear pair. If you break down the term linear pair, just the very word, it's a line. Pair means two. So two angles that form a line. And that's what I have in layman's terms right here. Two angles that form a line. The geometric definition, a pair of adjacent angles whose non-common sides are opposite rays. So angles 1 and angle 2 right here, these are two angles that when you put them together, it forms a line. That's a straight angle or 180 degrees. So angle 1 and angle 2 form a line. They are a linear pair. 3, 4, and 5, there's no way to kind of combine two angles together to make a line. So 3 and 4, there's no such instances of linear pairs. For 6, 7, 8, and 9, 6 and 7, this obtuse angle and this acute angle, bam, they make this 90-degree angle, or sorry, this 180, this straight angle, this line. It's a pair of angles that form a line. So angles 6 and angle 7 forms a linear pair. There's also 3 other pairs that are linear pairs. This angle 7 is acute, this angle 8 is obtuse, and together they form this line. So angle 7 and angle 8. Another linear pair. So it's kind of similar to adjacent angles because these linear pair angles are adjacent. Angle 8 and angle 9 are adjacent, but they're even more specific. They also form a line, a linear pair. So angle 8 and angle 9 is another pair. And then angles 9 and angle 6, this angle and this angle also form a line. So angle 9 and angle 6. That's what a linear pair is. Complementary angles. When two angles have a sum of 90 degrees, we call them complementary. Two angles whose measures have a sum of 90 degrees. So this box here in the corner of this angle means that the angle is 90. So angle 2 might be 20 degrees and angle 1 might be 70 degrees. 20 plus 70 makes 90. Or maybe angle 2 is 30 and angle 1 is 60. Same thing, you add two angles together. If they make 90 degrees, we call them complementary angles. So angle 1 and angle 2 are complementary. Are angle J and angle K complementary? Well, if one angle is 35 degrees and one angle is 55 degrees, are these two angles whose sum have a measure of 90 degrees? Yes. So angle K and angle L are also complementary. So now when it says, write a general equation to model complementary angles. So on this first example here, we said angle 1 plus angle 2, when you add them together, that sum is 90 degrees. For here, we said angle K plus angle J, when you add them together, it equals 90 degrees. So just to use a general equation, I'll just say, if we take one angle, I'll call it angle A, and we take another angle, I'll call it angle B, the sum, when we add those two angles together, that equals 90 degrees. That's what complementary means. Two angles that when you add them together equals 90. Supplementary, a similar term, but instead of two angles that add up to equal 90, it's two angles that add up to equal 180. Two angles whose measures have a sum of 180. Again, angle 1 right here is clearly obtuse. Maybe it's 140 degrees. Well, angle 1 and angle 2 form a linear pair, which means they form a line. And opposite rays have that straight angle of 180 degrees. So that means angle 2 has to be 40. 1 and 2 are going to be supplementary because they form a line. So which angles are supplementary? Angles 1 and angles 2 are supplementary. If two angles form a linear pair, they're also going to be supplementary. Oh, and I just did that for angle R and angle T. Angle 1, it could have been any obtuse angle. Maybe it was 110 degrees and angle 2 was 70 degrees. Whatever the case might be, no matter what, they're going to add up to make 180 degrees. Angle R is 140, angle T is 40. When we add angle R and angle T, we get 180 degrees, so they are supplementary. Angle R and angle T. So on the last one, when we wrote a general equation, we said angle A plus angle B equals 90 degrees. For supplementary, that means 180 degrees. So we're going to kind of use that same model. Angle A, we're going to sum, so it's going to add. Angle B, this time it equals 180 degrees. And there's a general equation to model every type of supplementary angle. Perpendicular. You've maybe heard this term before in algebra. Perpendicular are lines, rays, or segments that intersect at right angles, so 90-degree angles. Looking at our diagrams here, which of the following are perpendicular? Well, if I were to call this intersection point, point D, AD, this segment, intersects ray BC, and it tells us right here that the angle is 90 degrees. So they intersect at right angles, so we would say AD, that segment, is perpendicular, so that upside down T means perpendicular, to ray BC. AD is perpendicular to BC. Here on the second example, line B, line D has this box in the corner, and that box means that it's 90 degrees. So again, it's a right angle. So line B is perpendicular to line D. Lines M and lines N down here in this picture, are they perpendicular? It kind of looks like it, but we don't know for sure. This angle right here, it looks like it's 90, it looks like it's right, but it could be 89.5 degrees instead of exactly 90. If it doesn't tell us specifically, we cannot assume that it's perpendicular. So we cannot assume anything about M and N. We cannot say they are perpendicular. If we say segment HE and segment DF, are those two perpendicular? We can say that they are because this angle right here is 90. Because 67 plus 23, those are complementary angles. They add up to equal 90 degrees. So HE, that segment, is perpendicular to DF. Again, we knew that because we could add these two up and get 90 degrees. So we have to have some information. We cannot assume. Things that we can assume are these things. If it looks straight, it is straight. So you don't need to, take out a straight edge and measure if something is straight or not. If it looks like it's straight, we can assume that it is straight. If it looks like two lines intersect, then they do intersect. That's another thing that does not need to be proven. You can just assume that. You cannot assume these things on the right side, though. You have to prove those. Congruence. You cannot assume just by looking at a picture that two segments or two angles are congruent to each other. You have to have a measurement, or you have to know something about the picture. You cannot assume perpendicular. Again, an angle might look to be 90, but maybe it's 89, or maybe it's 91, or something like that. You cannot assume that they're perpendicular. The picture has to show you. And size is the third thing. All right, last thing here on this video lesson, name a pair of vertical angles. A pair of vertical angles would be angles that when two lines intersect are the ones that are across from each other, the non-adjacent angles. So here's BF and here's AD. So vertical angles would be this one and this one, kind of across from each other there. So angles A, E, B, and angle F, E, D. You also could have said this obtuse angle is vertical with this obtuse angle, which would be angle AEF. If you combine angles 1 and angles 2 together, you get BED. Angle BED. Name a linear pair. Let me get rid of my writing here. Clean up the picture a little bit. A linear pair are two angles that form a line. So here is a line, BF. So this angle and this angle, when you add them up, form this line, a linear pair. So there's one instance. We'll call that angle BEA. Here it is, BEA. And the other one is AEF. That's the obtuse one. AEF. You also could have chose another linear pair because there's another line up there. This right here is a line. So AEF and FED also are two angles that form a line. AEF, this one right here, and FED. Name a pair of adjacent angles. Adjacent angles share a vertex and share a common side. So in my layman's terms, it's two neighboring angles, angles that border each other. Angle 1 and angle 2 are two adjacent angles. Angle 1 and angle 2. I won't write the rest of them, but you could have said a lot of different examples. Angle 2 is adjacent to DEF. You could have said angle DEF is adjacent to this one, FEA. So there's a lot of different pairs of adjacent angles on this picture. Two angles that are right next to each other. Last question, are there any perpendicular lines, rays, or segments on this one? I don't see any angle measures as far as anything telling me that it's 90. I don't see any boxes in the corner of any of these angles and stuff like that. I can't assume that any of the angles are 90 degrees, so we would have to say no, there are no perpendicular lines on this one. I hope this video made sense to you. Lots of terms, linear pair, adjacent angles, complementary angles, supplementary angles, vertical angles. Be sure to let me know if you have any questions on this when you get to class tomorrow.